Okay, so for the first example, you could easily prove it by determinant, but if you don't know the determinant, then it's just this. So notice like this second row is twice of the first row. So this is the first column. So if you call this like, let's say V1, V2, so V2 is twice of V1. So therefore, this columns of this matrix are linearly dependent. So for the first matrix, so then I will say that V1, V2 is linearly independent, is linearly dependent, sorry, linearly dependent. Also, if determinant is 0, also if determinant of A equals 0, then it's also linearly independent. And determinant is just a product of this number. So 2 times 1 is the product of these numbers. So that makes that linearly dependent as well. So we just have to see. So the best way to do is reduce the matrix, row reduce echelon form, and look for the pivot, right? Let's say, for instance, for this one, I could multiply the row 1 by 3 times row 1 and add it to row 2, then this B will turn into this. This is the same, and this will be 0 because this is negative 6 added to 6, and this one is 3 times 5, 15, plus that is 23. So as you see, this is a pivot position, this is a pivot position, so you have pivot in every column. So therefore, this columns are linearly independent. So this is linearly independent. You can do the same thing here. Try to reduce this matrix to a row reduced echelon form, and I can just do this. I can do 7 times negative 7 times row 1 added to 5 times row 2, and put my answers in row 2. Then this will be reduced to, so this is the same, and this will be 0. Now multiply the first one by negative 7, that's negative 28, and add it to 35. So you're not going to get a 0 in this position. So it's 35 minus 28, that's just going to be 7. And you see, this is a pivot position, this is a pivot position. So you have a pivot in every column. So therefore, the columns of this matrix is also linearly independent. 7 linearly. And you could also check by determinant. So this times that, negative 16 minus 5 times 6 is 30. So determinant is not 0. So therefore, it's linearly independent. And do same thing here. 5 times 7, 35, minus 7 times 4, 28, and that's not equal to 0. So you see, in these two matrices, determinant is not 0, so it's linearly independent. In this matrix, determinant is 0, linearly dependent. So that's another way. And you can always do the row reduced echelon form. And if there is a pivot in every column, then it's linearly independent. If you're missing a pivot in a column, then it's linearly dependent.